Alright, so in the last video we introduced the z-domain, and we also showed how to, or we explained mathematically how to represent a z-domain. So just to review, this is the time domain or the n domain, and this is the z-domain, and this is how you can translate back and forth. This basically the coefficient of this becomes a coefficient of this. So now in this video we'll do an example of this translation. So let's take a signal which is represented by h of n, and if we have to, these are the coefficients of the signal, and if we have to translate this to so this is represented in the n domain, as you can see, and if we have to translate this to the z domain, this is what we will get. So this becomes capital H of z, and then we have, so this is at n equals to 0. So as you can see in the formula, we have x of k, so that becomes the coefficient times z to the minus k. So z to the minus, in this case it will be 0. Again, similarly for 0, then we do 0 the coefficient z to the minus 1. In this case becomes minus 3, z to the minus 2 plus 0, z to the minus 3 plus 2, z to the minus 4, and plus 1, z to the minus 5. So again, the coefficients copy over, and this was at the 0th time, n equals to 1, n equals to 2, and these are the time periods, and that becomes the k, z to the minus k. So that's just, you basically copy it over, so 2 to the z minus 0, 0 z to the minus 1, and so on. And then this thing can be simplified to 2 as anything raised to the power 0 is 1, and then this is just 0, and this is minus 3 z to the minus 2, this is 0 again, and this is 2z minus 4 plus 1z minus 5. So this is just really 2 minus 3z to the minus 2 plus 2z to the minus 4 and plus z to the minus 5. So this is how you can translate from h of n, a signal where you are given the coefficients, to its the domain counterpart. So now let's do an example where it's the opposite, where we're going from, we could do again from z, we can show one from z domain back to the time domain. So let's do that example once. So let's have a function, let's call it h of z, and let this be 1 minus 2 to the z minus 1 plus 3 to the z minus cube minus z to the minus 5. So as you can see here, the time interval is n here is 0, in this case n is 1, n is 3, n is 5. So these are the kth components. So these are the time intervals we're dealing with in this case. So when we translate this to that, to the time intervals, this becomes h of t, and this will become, this is just an impulse of n, and this is minus 2, n minus 1, and this will become plus 3. Again, same thing happens. You copy the coefficient, and then you change this, as you can see in this function. You copy the coefficient, and then this just becomes a part of the impulse function. So this is plus 3 and minus 3, and this becomes minus 2. Oh, sorry, this is z. I'm right pretty bad. So this is z to the minus 5. So it's just minus 1 or minus 1 and minus 5. So again, this was the z-domain formula we had for the signal or the function, and when this is translated to the time domain, that's what we get. This gets translated. 1 is 1, 2 minus 2 is minus 2, and so on. And that's the place. This is for the time with time delay 1, this was time 0, this was time delay 3, time delay 5, so this gets translated to that.